So in this video, we are going to talk about enthalpy, and we are also going to figure out how much energy is needed to completely decompose this gaseous PCl3. And before we start, please give the video a pause and give it a shot yourself. All right, so let's give the problem a read. How much energy is needed to completely decompose 612 grams of gaseous PCl3, which has a molar mass of 137.32 grams per mole, according to this reaction below? So let's give a look at this reaction, and we are given the delta H reaction, which is equal to 1207 kilojoules. And what this delta H reaction is the enthalpy of formation of the products minus the enthalpy of formation of the reactants. And so that's what that delta H value is here for the reaction. Okay, so because we have this 1207 kilojoules, this is per 4 moles of PCl3. So what we're going to do here is it is going to be 112.07 kilojoules. And the way that I am thinking about it is it's going to be simpler to do what it is, the energy that is generated per mole of PCl3. So what we're going to do is we're going to divide it by 4 moles of PCl3. And what this is going to give us is 301.75 kilojoules per mole of the PCl3. Because we are asked how much energy is needed to completely decompose this sample of 612 grams. So now that we have the energy that is released per mole, we need to figure out how many moles we have of this substance. So what we're going to do here is we are given 612 grams, and so for every 137.32 grams there is 1 mole of PCl3. And the grams cancel out. And so what this is going to equal out to be is 4.457 moles of the PCl3. So now that we have the number of moles that's in this sample and we know how much energy is needed to decompose 1 mole, all we have to do is times 4.457 moles times 301.75 kilojoules. And that is going to equal 1.34 times 10 to the 3rd kilojoules. All right, hopefully that helped. Please leave a comment. And I'm not doing this for the money. Thanks so much for watching. I really appreciate it. Bye.